I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will see the topic on binomial array for the course Antennas and Wave Propagation. So in this video, we will discuss the uniform distribution and non-uniform distribution of current amplitude in antenna arrays and about binomial array and its advantages and disadvantages. Now, the first part is uniform distribution. So the antenna current amplitude in arrays can be of two types. One is uniform distribution and another one is non-uniform distribution. So here a uniform distribution of antenna arrays gives the maximum directivity and the minor lobes are relatively large, which is the unwanted property of some particular applications. So the amplitude of the first lobe is 24% of the major lobe maximum. So in some applications this minor lobe amplitude is desirable and the pattern has a half power beamwidth of 23 degrees but side lobes are relatively large. So because of this reason we are going for binomial array. This binomial array is the array of non-uniform amplitude, and as per the demand of modern wireless communication where narrow beam, that is no minor lobe, is preferred, it is the greatest need to design an array of only main lobes. The ratio of power density of main lobe to power density of the longest minor lobe is termed as side lobe ratio. A particular technique which is used to reduce the side lobe level is called tapering. In binomial array, tapering is used, and since currents and amplitude in the sources of linear array is non-uniform and minor lobes are eliminated, and if the entire element is radiates more strongly than the other sources. Therefore, tapering need to be done from the center to end radiators because the center elements radiates highly strong, and this is of same specifications. And the binomial array is common example of tapering scheme, and it is an array of n isotropic sources of non-equal amplitudes, and the diagram represents the directive radiation pattern of an antenna from a parabolic reflector. And to reduce a side lobe level, John Stone proposed that the sources have amplitudes proportional to the coefficients of a binomial series of the form 1 plus x the whole power n is equal to 1 plus n minus 1 into x plus n minus 1 into n minus 2 by 2 factorial into x square plus n minus 1 into n minus 2 into n minus 3 by 3 factorial into x cube, etc. Here n is the number of radiating sources in the array. So if we propose the antenna like this, we can eliminate minor lobes. And in order to identify the amplitudes of individual antennas in binomial array, a simplest method is Pascal's triangle. So Pascal triangle is given in the picture. So for n is equal to 10, number of elements 10, it is given. So for an array of total length n into lambda by 2, the relative current in the nth element from the one end is given by Pascal's triangle. For example, the relative amplitudes for the array of 1 to 10 radiating sources are as follows. For n is equal to 1, according to Pascal triangle it is 1, n is equal to 2, it is 1, 1, n is equal to 3 is the first and last element are always 1, and the middle element is calculated by the previous two elements, and that is this 2 is obtained by 1 plus 1 of n is equal to 2. And similarly n is equal to 4 contains 1, 3, 3, 1. Our last two elements always 1, and the middle element is obtained by adding the previous row adjacent elements. So in this way Pascal triangle is designated. And now the activity. So now we are going to discuss about the comparing uniform array versus binomial array. So uniform array secondary lobes appear but principal lobe is short and narrow, where as in Stone's binomial array. Here width of the beam widens but without secondary lobes. So for linear array, half per beam width is 23 degrees, but in half per beam width of binomial array is 31 degree. So more beam width gives less directivity, which is not desirable. And now discussing the advantages and disadvantages of binomial array. First, we are going to see the advantages. So, reduced side lobe, which is the major aim of this binomial array. So, it minimize or eliminate the side lobes, and which in which applications where secondary patterns are undesirable, and improved directivity. So by reducing side lobes, the main beam of binomial array becomes more focused and directional, leading to better directivity. And beam steering and diversity is the third advantage, where binomial arrays can be configured to generate multiple beams with different phase patterns. This allows for beam steering and can be used in the diverse reception scenarios to optimize the receiver performance. Now, the disadvantages of binomial array. The two major disadvantages is, one is the directivity reduces, because while eliminating side lobes, the primary advantage of binomial array comes with the cost of reduced directivity. As the length of the array increases, larger current amplitude also required. So this is another disadvantage. And beam width is wider, as we discussed when comparing with linear array. And here this wider beam width can reduce the gain and also the directivity, as the power is spread over a large angle. So now the assessment. The major advantage of binomial array is, we know it is no side lobes. The excitation amplitude of the binomial array follow, we know it is a Pascal's triangle. Thank you.